Okay, we're in section 17, the section on complex fractions. We're going to be given fractions that contain fractions now. All right, there's many ways to deal with it. However, I want to point out the way we're explaining it to you is the way we'd like you to follow it. All right. Certainly, I'll go to the whiteboard, but we'll talk about, how to deal with a complex fraction. And, there's certainly a variety of ways of dealing with it again, but we're going to try to outline a procedure that we'd like you to follow. We write examples, though, that reflect that belief, though. All right. We don't write examples where that method we're giving you doesn't work. Now, granted, does it always work? No. We can write problems where this is really would be the worst thing you could possibly do. But the bottom line is it's an introduction to how to deal with problems like this, which are complex fractions. That is a fraction that contains a fraction. I realize, sometimes lectures really don't make much sense to students. We try to keep them incredibly short, though. What we're trying to do is we're trying to give you a very short lecture, what we'd like you to try to do. Then we're going to just pound this across by doing the examples. We hope the lecture material becomes more clear as we start doing examples, though. All right, so let me switch to the whiteboard. And give me 1 second. All right, let's take a look. Complex fractions, right? So the deal about this over here, I want to point out if you're given a fraction problem, point this out to you. If you're given a problem, I know this is written down for you, it's, A divided by B, and then there's C divided by D. I want to point out we have words for these things over here. This is the major fraction bar over here. It's major. All right. Then we have two smaller fractions. These are called the minor ones. Right. Now, granted, if I were looking at this and I was saying, how would you do that problem over there? I'd say, oh, that's a division problem. And I would write this down then. I'd say this is A divided by B. That's a top number divided by the bottom number. Then I would say, oh, I don't like that division symbol. What do I do? What I did in the past section, I'd write this as A over B times the reciprocal of C over D, which would be D over C. And what we get there? We get AD over BC. And there's nothing wrong with that. That's what you've done in the past. Certainly when you're in grade school, you were told to do that. You can continue to do that. There's trouble with this, though. We also write problems where if you don't follow what the trouble is, you're going to get into trouble fast. All right. And I want to give you an idea about what I mean by that. And what we're going to try to do is come up with a better method than what you just there, which is basically, taking a division problem, rewriting it as a multiplication problem by taking reciprocals. So let's write this down. So I'm going to put this over here. Whoops, sorry about that. Got to get back to my ink here. This is 3/4 plus 1/2. And I want to go through what you did in grade school for this problem. Right. In grade school, what the teachers made you do was add the top two numbers together first. I want to tell you why this is. This over here is a grouping symbol. So it says you have to deal with these two guys over here and deal with this group first. Well, that's not too bad. And certainly some experience. I know the common denominator would be 4, right? And what would you get over there? Well, 3/4, that's 3/4, plus what times 2 gives you 4? 2. 2 times 2 is 4, and 2 times 1 is 2. So the top number is 5/4. All right, let's do the bottom number. What do you get over there? Again, it's a grouping symbol. This is a grouping symbol, this long fraction bar over here. So you have to do this group over. There's 2 members in it. You got to get an LCD. And what's the LCD over there? 12. Well, what times 3 gives you 12? 4. 4 times 2 is 8. Minus what times 4 gives you 12 is 3. And 3 times 1 is 3. What do you over there? 8 minus 3 is 5. 12ths. All right. Let me point out what we have over here. And there's still a fraction. It's this guy here divided by this guy over here. Now, someone says, why didn't you do it in the beginning? It would have been too difficult. All right, let's put this down. 5/4 divided by 5/12. Well, the bottom line is I can rewrite this as a multiplication problem with the understanding I need the reciprocal of this. I put that down. 5/4 times 12/5. All right, what's nice about this? Reductions. 5 goes into 5 once, 4 goes into 12 3 times. What we left off with, 3 divided by 1, which is 3. All right, I'm going to write the problem down again. And what some students do is they try to do this over here. And by the way, they're going to skip a lot of steps to get to a wrong answer. It's the top divided by the bottom. What students try to do in their head is get this guy's reciprocal, and they can't do it. Or if they do it, they do it incorrectly. I got to tell you, though, we have a better way of doing it. And I want to go through that with you. So I'm going to be taking the problem over again. It's going to write it over again, and we're going to recommend you do something in the problem. Initially, a lot of students are resistant to doing this. I want to claim, though, we write problems that reflect this method. We'll go through it. I can't say slowly, but we'll go through it. There's a fraction bar here. This is the longest fraction bar I'm seeing. We call this the major fraction. These guys over here, there's 2 fractions on top. There's 2 fractions on the bottom. What we'd like to do is look at all the little tiny fractions in the problem and come up with their LCD. We call that LCD the minor LCD. I want to look at it, and for the most part, it should be relatively simple. Well, I'm looking at 4 different fractions, 4, 2, 3, 4, and I want their LCD, right? 4, 2, 3, 4. Well, if you have to, you could factor all these numbers, right? I'll write that down for you. 2 factors as 2. 4 factors as 2 times 2. 3 factors as 3. 4 factors 2 times 2. It's already down. What's the LCD? I need a 2. I need a 3. What's the maximum times a 2 occurs in anyone's factorizations? Twice. What's the maximum times 3 occurs in anyone's factorization? Once. What do you get there? 4 times 3 is 12. So the minor LCD is 12. Let me get my eraser out. This is old business. We've done this for some time now. What we're going to recommend is to take the minor LCD and use it as a builder. So we're going to multiply the top by 12 and the bottom by 12. What's 12 over 12? 1. It's not going to change the fraction. Here comes the trouble, though. We got to take this 12 and distribute it across these 2 terms. I'm going to write that down for you. In time, you'll get faster. Let me put this one. I'll do this over here, right? Against the 2 terms, by the way. Across the 2 terms. Let's take a look. 2/3 times 12. Oh boy, I made a mistake again. All right, 1 step at a time. 4 goes into 4 once, goes into 12 3 times. 2 goes into 2 once, it goes into 12 6 times. 3 goes into 3 once, it goes into 12 4 times. 4 goes into 4 once, it goes into 12 3 times. Yes, I know it's a lot of writing. In time, it'll be much simpler. What do you get on top? 3 times 3 is 9. Plus 1 times 6 is 6. What do you get on bottom? 2 times 4 is 8. Minus 1 times 3 is 3. What's 9 plus 6? 15. What's 8 minus 3? 5. What's 15 divided by 5? Is 3. Are we getting the same answer? Of course we are. Now, some of you say, oh, they're all just a bunch of work and I just don't know what to do. I can't say this enough times. We want to do this method over here. That's what we're trying to learn now. We'll go through examples. Hopefully when I go through examples, everything will be made more clear. What's being made more clear? That we have a technique. We write problems that where this technique is going to work pretty nicely. Does that mean you can't try different techniques? No, you can try what you like. Just make sure that you know what you're doing and you convince yourself that there's only one possible outcome to these problems. And we know what the outcome is. And we put that down for you in the answer key for you that you should inspect as you're doing the problems. Again, I'll go to examples next. Thank you.